Hi Roselle, thanks for your questions. I'm going to try to explain this as well as I can here. This question, it has to do with the understanding that the logarithm and the exponential functions are inverses of each other. And so in this particular example, they've got an exponential to a log. And so in general terms, if you have an exponential like a, to the log of a, so the base of our log is a, let's say of x or something, then the log and the exponential cancel each other out and you just end up with x. Now that works the same way if you did it the other way. If you have log base a of a to the x, so you've got the log of an exponential with the same base, then that comes out to x as well because it's the inverse. They're the inverse functions of each other, and so it just comes out to the x. So if you can sort of understand that rule, it's going to work all the time. Then the solution that you've included here for this question works the same way. So what happens is, I would write this just a wee bit differently. When they have the 3 log base 6x, so they have that written like this, 3 log 6x, then that 3 comes over here and becomes the exponent on the x. So we have log base 6 of x cubed, like that, okay? Now that makes it much easier, I think, to see what you're going to get when you take the exponential. Like you've got a base of 6, so you're making this into an exponential. So you're taking the exponent of a log like this. So if you compare those, because the bases are the same here and here, then all you end up with is this portion of it for your answer. So in the solution that they've given, they've written the whole thing cubed. I prefer to write it when you have a coefficient in front of the log, like here. I prefer to write it as just an exponent on that variable. So like 2 log base 6 of x would be x squared instead, log 6 of x squared, and so on. It's much, much easier for you to take that coefficient and just make it an exponent on the variable, which is essentially what it is. And then you can go the other way too. If they give you log of x cubed, you can write the 3 in front if that makes it easier for calculations and things like that. So if you do that, I think it makes it a little bit easier to see. So another example maybe might help if we think about in a case like this one. Let's say I gave you like 5 to the log 5 of x cubed or something like that. Then the exponential and the log cancel each other out, and the only thing that you end up with is just the x cubed as your answer. I don't know if you're doing lns yet, but it works the same way with the lns. If you have a base e to the ln of x, and that just turns out to be x because the base for ln is e. So I'm not sure if you're there yet. Don't want to confuse you, but if you are, maybe that will help you when you see those as well. With this other equation that you sent me, I'm just wondering what's the best way to explain this one. I think if we start at log 3 to the x to the 3, and I'm going to write equals y here, because if we write it back in exponential form, it would mean 3 to the x to the y equals x cubed. Sorry, equals, no, I messed that up, I'm sorry, equals, I knew that when I looked at it there, equals 3. I was looking at the wrong, I was looking at the x here. Okay, so 3 to the x is the base, and so if I take that base and put it to this exponent, then that's where I get the 3 to the x to the y, and then it has to equal 3, and 3 we know is just 3 to the 1, right? And so basically all that means then is that the exponents have to match because the bases match. So xy has to equal 1, And when we're solving for y, we get 1 over x. And that's all there is to it. It looks a lot more complicated than it really is.